SASE, or the Secure Access Service Edge, is a term coined by Gartner in the summer of 2019. It's a model or a framework or an architecture that describes the necessary WAN edge network functions combined with cloud-delivered security services, all delivered and managed in the cloud. Now, none of these are new technologies or capabilities. It's just that the integration of these network and security functions have been given a name, SASE. The necessary WAN edge functions include SD-WAN, of course, routing to communicate with the world outside the WAN fabric, basic security functions to protect the branch from incoming threats, such as a zone-based firewall and segmentation, perhaps even IDS and IPS, application and network visibility, and even WAN optimization. Ideally, all these functions are unified and managed in a single WAN edge platform that greatly simplifies branch WAN edge infrastructure. And Gartner calls this a thin WAN edge. These WAN edge functions are married with cloud-delivered security functions that include firewall as a service, secure web gateway, cloud access security broker or CASB, zero trust network access or ZTNA, data loss prevention, DLP, sandboxing, which is the ability to run an executable file in a protected environment before passing it along to its final destination, antivirus, intrusion detection and prevention, and more. But why do we even need SASE? Why do we need a new security architecture? Well, the data center is no longer the center of the universe for most enterprises today. If we look back a dozen years ago or so, all enterprise applications were hosted in the data center. All users, regardless of where they were located, where they were working, connected back to the data center to access their business applications. An enterprise could build a moat or a fortress around the data center to protect it. Users connected from branch locations over secure private line connections like MPLS, or from remote locations using virtual private network or VPN agents installed on their devices. And this model worked fine. But then along came the cloud, SaaS apps like Salesforce.com, ServiceNow, Workday, Box, Dropbox, unified communications as a service apps like 8x8, RingCentral, Zoom, and now Microsoft Office 365, the most widely used SaaS application in the world, and many, many more. The cloud also includes infrastructure as a service providers, or IaaS, like Microsoft Azure, Amazon AWS, Google Cloud Platform, and others. But sending cloud traffic that's destined for the internet back to headquarters simply doesn't make sense. It adds delay that degrades application performance, and it consumes costly leased line bandwidth. Why not use the internet to reach apps that are hosted in the internet? Now, this has driven the rapid adoption of a more intelligent, application-aware, software-driven or software-defined model for the WAN, an SD-WAN. But what about security? With the increase in remote workers connecting directly to cloud apps, traditional perimeter-based security is insufficient. By transforming WAN and security architectures with SASE, enterprises can ensure direct and secure access to applications and services across multi-cloud environments, regardless of the location or the devices used to access them. And keeping cloud security enforcement points up to date with the latest threat intelligence and remediation measures is far easier than doing so with firewalls deployed at hundreds or thousands of branch locations. Cloud-delivered security services place security enforcement closer to the user instead of backhauling that traffic to a headquarters or hub site for inspection. And cloud security enforcement points are usually deployed in the same data centers where common SaaS apps are also hosted. Application response time is significantly improved by connecting users to security and cloud-hosted application doorsteps that are closer to where they're working. Here's a quick example. If I'm working here in Silicon Valley, California, and have to connect to a headquarters location in New York for security inspection, my traffic incurs a 70 millisecond to as much as 100 millisecond delay. Doesn't sound like a lot, but this delay stacks up with every transaction, and it slows down my application performance and my app response time. This frustrates me and makes me less productive. The real goal of a SASE architecture is to more intelligently connect users to their applications without compromising any security. And the business benefits of SASE are many, including improved business productivity and customer satisfaction, enhanced consistent security policy enforcement across the enterprise, reduced risk and brand image protection, increased IT efficiency, and lower overall WAN and security costs through centralized management, the ability to evaluate and easily adopt new security technologies as they emerge. Thank you for joining us today.